Hey everybody, welcome to the 6th grade podcast. This is Miss Brown. I'm joined by Miss Canario and Mr. Goranto. We're going to talk to you pretty briefly about some wind. We're going to talk about how the sun's energy produces that wind. And we're going to discuss the relationship between air pressure and wind, and also go back to some global wind patterns, as well as look at the local causes of wind patterns.
All right, so let's just talk about why wind forms in the first place. So this is probably the most important thing we're going to say the entire podcast. Pressure differences are caused by the uneven heating of the Earth's surface. Okay? That's what causes wind. Differences in pressure, which are caused by uneven heating of Earth's surface. Okay, so if we look here at the Earth, okay, and we're looking at the sun's rays and how they're shining on the Earth. We look at the sun's rays and the way they hit the Earth based upon the different places on the Earth. Okay, and we take like the surface of the Earth and we say, okay, that set of rays is hitting that surface area. Okay, these rays that are hitting directly at the equator are hitting in a direct angle, and they're hitting that amount of surface area. Whereas these rays who are hitting at the other pole are hitting that amount of surface area. When we look at it, we say, okay, if each of these different sets of rays are representing the same amount of sunlight and heat from the sun, then they're being spread over different size of areas on the Earth. So if we look here at the equator, all of that heat is being kind of concentrated right there in a smaller area at the equator. But then we come up here and we look at the areas in the poles, the same amount of heat is being spread over a larger surface area. And that larger surface area is going to cause that heat to be more spread out and for it to be colder. Guys, that is why the poles are colder than the equator, because the same amount of heat is being spread over a larger surface area, and so the heat is being spread out. Okay, there's also, if you look at it, there's another reason. The equator is actually physically closer to the sun than the places on the poles. So not only are they getting less amount of sunlight and the sunlight's being spread out over larger areas, they're also just physically further away from the sun, causing the poles to be colder than the equator. Okay, so we go back up here and we look at this uneven heating of Earth's surface. That right there tells you how the Earth's surface is being heated unevenly. All right, so let's look and see how that forms wind. Okay, it's all about convection. Remember, convection we talked about on the last podcast is when warm rises and cool sinks because of differences in density. All right, so the convection of the air creates different pressures. All right, so that warm air, that in the case that we were looking at the last picture, we were looking at the equator, that warm air is going to rise. It's going to rise because it is less dense. When it rises, it creates an area of low pressure. Okay, think about if somebody's pushing down on your shoulders and they start to move upwards, they start to rise, the pressure that they're pushing down on your shoulders is lessened. There'll be a lower amount of pressure pushing down on you because they are rising. Same thing with the air. If the air is rising because it is warm, it leaves lower pressure. Okay. On the other hand, the cooler air, which in the example I just showed you was at the poles, is going to sink because it is more dense. Okay. If it sinks, it's going to fall onto the Earth more heavily, creating high pressure. Same analogy with somebody pushing down on your shoulders. If they start to sink down further and push down more onto your shoulders, that's going to create more pressure pushing down on you. So rising warm air creates low pressure, sinking cool air creates high pressure. Now, because there are different amounts of pressures, that's going to create wind. Okay, down here, number 4, look here. Wind moves from high to low pressure. All right, so if we look at this diagram right here, we've got a warmer area that has higher pressure. It's going to cause that air to rise. Okay, that air is going to move up into the atmosphere. It moves through the upper atmosphere and it gets cooler, right? And so now that's over here, it's cooler, it's going to sink back down and create higher pressure. And again, finish the convection current by moving over and replacing that high air that leaves. So the high air rises, it's got to be replaced by something. So this air blows across the surface of the Earth, and that right there, this air blowing across the surface of the Earth, is the wind that we experience. Okay, so that happens in lots of different places all over the Earth, just depending on how the Earth is heated. It creates these convection currents like we have here that go from high pressure here where the air sinks, and then the wind blows from the high pressure area to the low pressure area until it rises, and then it completes the convection current in the upper atmosphere. Okay, so wind moves from high pressure to low pressure. I like to think of that like if you've got a chip bag and you're, like it's an unopened chip bag, like let's say a bag of Doritos, and you press really hard on that chip bag, you're creating higher pressure on the bag than what's outside the bag. So the air eventually is going to give in, and it's going to blow, it's going to pop the bag open, and the air is going to go from the high pressure to the low pressure. And that's exactly what happens in the atmosphere when we have higher and low pressure air in the atmosphere.
All right, next let's look at the global winds and how that affects the winds. So global winds are winds that move between certain latitudes on the Earth. So remember, go back in your brain and think back to when we talked about surface currents. We talked about something that causes the surface currents to move. That was the Coriolis effect. The Coriolis effect is the spinning of the Earth, which causes these winds or currents to curve. So they're curving depending on where they're located on the Earth. Remember, in the northern hemisphere, above this line, they're going to be rotating in a clockwise direction. If they are in the southern hemisphere, they're going to be rotating counterclockwise. So you should remember that from our conversation on currents.
So now we're going to talk about local winds. Local winds you may hear like sea breeze or land breeze, or more appropriately to hear for us in East Tennessee, we're going to hear mountain and valley breezes. But these local winds, they're just based on temperature differences. Like Ms. Canario said earlier, wind's going to blow from high pressure to low pressure. Well, now we're localized. We're not spreading it out over a large latitude. So we're looking at just an individual area. So in this case, we're looking at the sea breeze. So sea breeze and land breeze, the name is based on where it's blowing from. So a sea breeze is blowing from the sea to the land. And the land breeze, just the opposite. It's blowing from the land to the sea. Now, what causes this is just temperature differences. The ocean or the sea is going to hold its temperature much better than the land can. So the ocean's temperature is going to be pretty consistent. So if we look at this example here, it shows at 12 o'clock, the ocean temperature is 65 degrees, the land is 85. Now, as we went through the day, now it's 6 p.m., land is 65 and ocean's 65. What's happened to our wind? We don't really have a wind blowing right here because there's no pressure difference. So we have to have the pressure difference for the wind. Now, we've moved now to 10 p.m. Now the land is 55 degrees and the ocean 65. So the land has a lower temperature, so it's considered a high pressure area. So the wind is going to blow from land to ocean. If we continue, then we take it back to 12 p.m. The land's 85 degrees, the ocean's 65 degrees. Again, the higher temperature, remember we said before, warm air rises. So if warm air is rising, it's creating a low pressure. Cold air sinks. The colder temperature is going to be a high pressure. So this is my high pressure here on the ocean side. So it's going to blow towards the land. This is a sea breeze. Again, remember, it goes the direction it's blowing. If it's blowing from the sea, it's a sea breeze. If it's blowing from the land, it's a land breeze.